I'm the general manager for Amazon open source engines. These engines include RDS for Postgres, RDS for MySQL or MySQL, if you like that way, and RDS for MariaDB. I'd like to thank all of you to join with me in the morning in my talk for what's new in open source databases. I think the content of my talk would go over some of the things that we are working in the open source and also talk about like the new innovations coming in the open source databases, along with the other databases that we do provide from AWS. So that would be the content of the talk. To begin with, thank you to Percona for giving us the opportunity to be out here. Each year we enjoy Percona conferences and talking to people across the collection of the open source communities that do attend out here. So to begin the topic, right, I do want to set the context first. I'm going to talk about developers and why developers like open source. To kind of like frame it correctly, developer is a person that develops something. Could be anything, needs to be creative, right? The primary expectation from a business point of view is like solving their business needs. But the way it works is like, to solve a business need, you also solve technical needs out there. In this context of the talk, I'm going to go more after the database developers. The way I actually define a database developer is it's a wide persona that could develop on the database, in the database, or for the database, right? To be in a true sense, there is no single database developer. You have developers working in the engine side of it, developers working on the integration side of it, developers working on the application side of it. So that's the context. Why do developers love open source? Because I think it just works. Like, if I have to just put it simply, open source databases works for developers. They love the agility and the speed of it. They love the innovations that comes from it. They love the low cost of starting on it. And it provides them with the flexibility. And since the code is available for everybody else, the communities can work together with the developers to kind of solve the needs out there. So in context, like, the thing that brings the open source closer to a developer is the openness, right? Being able to understand how it works, being able to kind of tweak it to fit their needs, and be able to be more creative about it. AWS actually supports 50 plus open source technologies in the area of databases, AI, ML, analytics, and the broader portfolio. I don't know, like if you notice it, there are a lot of customers that use open source on AWS. We like to say like 90% of what we do is based on the feedback of customers on what they would like to use on AWS. So the way we do that is we take those requests in, provide an offering around it, and then we provide you as an option to kind of run it multiple ways. You could run it directly, self-managed on EC2. We do provide managed offerings around it. And then we also do innovations along with the customers to kind of solve specific needs for their businesses. We support all the way from Linux operating system to Kafka to multiple of the open source databases. And also we try to kind of make it, our goal is to make open source available to a wider set of customers who could not use it before. So that's what we aim to do. How do we do that? AWS has a contribution commitment to open source. We do it in multiple ways. We actually give back code contributions. We not only fixes bugs, we also do incremental features on top of it. Then we also accelerate innovations around it. We look at the problems that customers face on it, the users face on it, and create new projects around it. We'll talk about some of those projects in the later slides, but our commitment is we want to kind of grow the community of open source developers and the users around it. We see the passion of people who work in open source. We use that as a way to kind of enable to kind of innovate and develop on it. In the next few slides, I'll talk about some of the contributions and innovations that we are working along with the open source. and kind of like go through them and recognize few of the people from AWS and outside AWS who are working on it. So for my first spotlight, I think this is very recent, so it actually makes sense about it. If you have used Postgres logical replication, you know the challenges that are going on to kind of like use it at scale, especially for a wider use cases. So one of the things that we specifically contributed, and it's actually accepted recently, which will be going into Postgres 16, is a specific feature which would allow you to do parallel apply through logical replication in Postgres from your source database to your target database. If you kind of like look at the current state of the logical replication, a logical replication, when it replicates, if you have a large transaction, it used to apply it serially, which often for a database with like high load on it could take forever if you're trying to apply it serially. So what we did is we recognized the fact that it's a problem. We actually worked with the community. We actually partner up with some more engineers from Fujitsu and worked in the Postgres community to create a patch that would now actually apply those logical updates in parallel. And we contributed it through the hackers list, and it went through the reviews. It does take a long time, as we all know, for any contributions, but we actually worked with the community to go for the design and the implementation, and it got actually accepted recently. Again, some of these bets are long-term. This will actually show up in Postgres 11 when it goes GA. Postgres 16 beta would be just announced recently. So, we are waiting for that to kind of let people try it out and give feedback before it goes GA later end of the year. So that's the type of long-term commitment that we want to do with the community and continue on that. The next example I want to talk about is in a similar space. If you have used Postgres logical replication, you know that you could only use it from the primary source all the time, which is a challenge because many customers, when they are running production workloads on their primary instances, want to offload all replication from other standbys or replicas out there. So this was another thing that a couple of AWS engineers, Masahiko and Bertrand Drouot, actually worked extensively on it to make sure that logical replication actually can work from a read replica. Because in the prior case, it need to be either the primary instance or a read-write instance all the time, which would put more load on the main instance. With this change that will be coming again in Postgres 16, you'll be able to kind of offload it to a read replica and be then able to kind of scale out more. This is an exciting feature that I'm actually looking forward for us to kind of support soon as it comes in Postgres 16, because this is a way to kind of be able to kind of scale out more in Postgres with these new features. Postgres is not the only community that we work extensively. The next one I want to talk about is MariaDB. Recently, earlier this year, in MariaDB 10.6, we actually found an issue in the release that when you restore a database to a new database name, not the same name as before, it would actually have problems in recovering from the backup. This was actually a pretty hard one. We encountered it. We actually debugged into it. We eventually found that the server ID, the UID, is actually stored in the backup snapshot, which was preventing it from restored if you change the server ID out there. So we worked on the fix and contributed it back, and it got accepted into the MariaDB community out there. So now it's part of the next minor releases of MariaDB. The work was primarily done by Hugo and Otto in our team to kind of contribute back. And that's the way we kind of continue on working on, core engine changes. It's not always the core engines that we work with. We also kind of go for projects associated with it. For example, what we did with one of the audit plugins, which was traditionally available only for MariaDB customers, we took that plugin and made it available for MySQL customers too. When MySQL 8.0 came up, we found that the plugin no longer worked because the plugin architecture in 8.0 changed significantly. So we invested the effort to kind of rework it for 8.0 and then support it for 8.0. So like 5.7 is when the API changed on the MySQL side. So we ported the MariaDB audit plugin to 5.7 and 8.0 and released it as a GitHub project for everybody to kind of use out there. So our aim is to kind of like continue doing innovations in the open source side for our customers and users out there, and be able to kind of like, make sure that the community is growing with a wide variety of choices for them. And to kind of like go outside relational databases, one of the recent contributions that was done earlier this year was in the Redis side of things, where Karthik Subbarao actually created a module to allow authentication, which is different from the default Redis hashes out there. So now you could actually use this to plug into any different authentication system that you want in Redis. It could also be used to kind of like federate authentication, supported to like HashiCorp, Vault, and other ones. So it allows you to kind of like, extend that feature out to support non-standard that comes from the database itself to like more popular authentication systems. So these are some of the ways that I want to highlight, like some of the contributions that AWS is doing on the open source side of it. And continue to kind of work directly with the developers in the community itself. Next, I want to talk about why should you run open source on AWS? Our aim is to kind of leverage open source innovation, bundle it with AWS innovations, and provide it to the customers. AWS actually, if you know, has a long history of operational excellence on providing this thing out. And that's what we strive to do. What are the undifferentiated tasks that we could actually make it very simple for our customers so they can innovate on the innovations and the features that come from these open source databases, integrate it into their applications, and provide it for their end business needs out there. So what does AWS provide out there? It provides it from server provisioning, patching, backups. Our aim is to kind of make it as simple as one click for everything as you want to do for it, to kind of not be worried about it, and then allow you to kind of keep focusing on application development and benefit from the features as such. What we aim to do is give you high performance at scale, high availability, and disaster recovery for all these services. So these are the things that you don't need to spend time worrying about, and just focus on the app development, the business needs that it needs to fulfill for your companies or your hobby projects, and continue on it. The way we do that at AWS is to kind of provide you with a purpose-built service for your needs as such. We have probably one of the broadest services out there. Our aim is to kind of give you the right tool for the right job. It varies from very specific needs in the relational side that we typically serve with RDS and Aurora to the non-relational databases that can go from your document structures or graph databases and so on. So in today's topic, we'll probably be focusing more on the open source and the open source compatible offerings from AWS. We'll talk about some of the innovations that are happening in the spaces. And we'll probably start with the relational database because that's the topic closest to my heart as such. So the first one we want to talk about is Amazon Aurora, which is an open source compatible in the way it's MySQL compatible and Postgres compatible out there. It's designed to be kind of just replaced out there, gives you the simplicity and cost effectiveness of an open source database at the price point of a commercial database as such, 1/10 the price point. That was the original aim when we released Amazon Aurora. The way we innovate in the space is to kind of keep on giving more performance improvements, keep on giving the features that people typically expect from commercial databases out there, and provide you with a fully managed service around it. One of the things that we constantly do up there is I will keep repeating, but we take the feedback on what problems customers has on it, and we solve it through innovation in this space. One of the latest announcement that we recently did was Amazon Aurora IO optimized offering. For people who already used Amazon Aurora, what you would find is there were certain cases where if you have an IO intensive application, you would be sometimes surprised by the pricing on your IO. And this one is specifically designed to kind of address that concern out. So if your spend on Amazon Aurora grows beyond say 25% just on IO, then this is the offering that you could potentially just apply to your instance, and that gives you more predictable pricing for your IO. What we have noticed is if you're spending more than 25% on your IO, by choosing this option, you will be able to kind of retrieve about 40% savings on your cost that you do on your total spend on Aurora. And I think the feedback that we are hearing is this would actually be something more useful for customers who like predictable pricing, where you are able to kind of take a fixed price and apply it on a monthly basis. This option applies to both on-demand as well as reserved instance pricings. So you have enough choices of selecting the original one, which is now called as standard pricing, versus the IO optimized pricing. So you have a choice on which one fits well for your needs. If you ask me, if your spend on your IO is 25% or more, then this is the option that you want to select to kind of get the maximum savings on it. Sure.
Would there be any benefit for someone to still do standard pricing?
If you're not paying too much on your IO already on it, there may not be much benefit. This one is actually designed if your spend on IO is 25% or more. So you would see actually benefits for that. Yeah.
When you say 25% of total Aurora database spend, does that mean this price spend on instance?
Yeah, so on the standard, you have three styles of pricing: the storage, the IO, and the instance. With the IO optimized pricing, you only have instance and storage pricing. That's it. It simplifies it to two levels. Thanks. Moving on, the next integration innovation that we have in the space of Aurora is the zero ETL integration with Amazon Redshift. This is already available as a preview for customers using Aurora with the MySQL compatibility. The idea behind is to kind of we see the need, a lot of people use Aurora as an operational database and Redshift as the analytical data store, and we're doing their own ETL conversions behind the scenes to take the data from Aurora to Redshift. With this feature, you now actually get an option to kind of turn it on automatically, which does that translation behind the scene and makes the data available from Redshift. If you kind of look behind the scene, what the option you have is you enable it at a database layer. It sets up an ETL transformation from Aurora to Redshift. Even if you do schema changes on Aurora, it recognizes that and makes those same changes on Redshift. And then you could create materialized views on Redshift to kind of get the analytics in the form that's easier for you to consume, and it's fully managed behind the scenes. So it kind of takes away your work that you need to kind of spend manually in taking the data from Aurora and putting into Redshift and managing it yourself. Yeah.
What's the sync lag, or how long does it take to?
It is close to real time, but not real time, because it's still a batch job that happens behind the scenes. So it continuously takes a set of data and kind of replicates it out there. The batch actually runs quite periodically, so we expect within minutes to show up on Redshift out there behind the scenes. Okay. The next topic that I want to talk about is guard duty. This is more specific from the security viewpoint of databases. We recently announced a guard duty for RDS protection. We started with Aurora, so that's the first set of databases that we are supporting with guard duty. It is actually designed to kind of like protect the perimeter of the database. So for example, one of the things that it does in the first release that we have is it would take and identify all the suspicious login attempts that are happening on your databases. This is useful for people who want to kind of prevent denial of service or ransomware type of attacks and want to kind of understand that. What GuardDuty does is it takes telemetry data collection from the database. Doesn't impact the performance of the database because we already have a way to kind of like collect those database and stream it out. So it uses that data and then provides you with the findings in the GuardDuty console. You can actually use that same data and forward it to your own security product that you have. So it's actually designed to kind of reroute it somewhere else if you want to do it. But you will find like all those tools then get integrated into GuardDuty where you have more control over it. Our aim is simple. We want to kind of like make it easy to enable for people to kind of tap into it. It uses machine learning behind the scenes. So it kind of uses like contextual data for like, you can say like, these are the type of applications using it for this purpose. And if it recognizes something that's going differently out it would actually prompt on it and like give you an alert that you can take actions on. So we're kind of like excited by, the protection that it provides it. We are starting with the Aurora databases, but we'll be expanding it to the rest of the RDS engines that we support. Next, I want to talk specifically about the open source databases. Sure. So right now it's designed for the suspicious login attempts. So if there are anomalies around those login attempts, then yes, it does provide you of them. So the next one I want to talk about is RDS. As you know that RDS supports multiple engines, including commercial engines. For today's presentation, I'm only going to focus on open source databases. What RDS aims to do is provide you with an easy to use managed database service and give you the performance and the high availability and the durability guarantees on it. We do have SLAs on multi-AZs, which actually customers use them to kind of like put trust on that system. RDS first came out in 2009, so we now have over 10 years of operational excellence that we use to provide like security, best practices, and provide innovations around this space. So for today's session, I want to talk about some of those most recent features that we have announced on RDS, specifically for the open source databases. The first one I want to talk about is optimized write. This is now supported on MySQL and MariaDB databases in RDS. It's designed to kind of like give you the 2x improvement in the write transaction throughput that could help you to kind of get more out of your possible throughput on your instance size that you select. For example, like, oftentimes you would find your databases are limited by the system resources itself. Could it be CPU, memory, disk, or the network throughput? This one is designed to kind of give you more throughput based on the writes. How does it do that? So let's talk about that. What optimized write does is it actually uses a feature called tone write protections. We all know that MySQL page sizes are 16 kilobytes, which in Linux, if you go traditionally with a 4K page, 16K write could be broken into multiple pages. With this feature, we kind of like use a feature that is provided from the AWS Nitro systems that gives you protection for tone page writes, and we up-level it all the way to the database. How does that help? It gives you the guarantee your writes are not will not be broken from 16 kilobytes into smaller chunks. What's the advantage that we could use it for? MySQL specifically uses something called buffer writes, just as a way of protecting tone write pages. With this feature, we now automatically turn off that double write because we now have protection in the stack itself for tone write protections. And this now gives you a 2x boost, because now for every write that you do not need to write into a double write buffer. And this kind of gives you as the performance improvement out there. The way we do that is we kind of like work it out for the entire stack. So this works on new instance creations, because now that's where we control it right from the beginning, all the way from the storage to the file system to the database, and have a protection on it. So with new databases that you create on AWS, specifically like 8.0, I believe 32 onwards, and MariaDB 10.6, and some of the recent minors, you will be automatically getting optimized write if you select the most recent instances, like R6, M6G, M7G, and so on, with this feature out there. So this to me is like one of those innovations, like how we apply both the open source ways of doing it combined with the system features to give you like more benefits for the end user out there. The next feature I want to talk about is optimized reads. It's in a way similar, except we do it slightly different for the reads. Oftentimes, like databases take a lot of things, the temporary objects, the sorting and everything in memory, and often they spill that down to disk to kind of like protect it, and also like be able to kind of like do more of those sorting. That overflow typically in the old days was going back to the database directory itself. And one thing that we found is, instead of doing that, if you put it on the local NVMe storage of the instance, you could get another about 2x performance boost for this type of operations. So we now started supporting instances with local storage in RDS. And this feature is actually now supported for all three engines, MySQL, MariaDB, as well as Postgres. So if you select an instance with the D instance types typically, which has like an internal NVMe RAM, it will automatically configure the database to put all the temporary objects onto that local disk, giving you out-of-box performance improvement for any type of long-running queries that uses a lot of temporary tables, a lot of sorting behind the scenes. You'll see performance boost happening automatically behind the scenes for you. So this is another way, what we want to do is like take out the pain of configuring it manually and just providing it to you as like a simple one-click deploy. Depending on the type of instance that can support that feature, enable it automatically. If you are using, we also have different deployment models like multi-AZ with 2 readable standby. On the Postgres engine, when we did the release, we also enable optimized reads on that multi-AZ with 2 readable standby, which we also call as the multi-AZ DB clusters. So a lot of the feature that we do also applies on all the individual deployment options you have. So customers need not worry about like getting, what's the right configuration to get the max performance out of that setup. Moving on, the next innovation I want to talk about is trusted language extensions for Postgres. This is a feature we think it's more in the developer space of it rather than just like the administrators. The reason we wanted to do this project is like, if you know about Postgres, extensions are the key piece of Postgres. There are thousands of extensions available on Postgres, and most of them are written in C or SQL languages. The challenge with extensions are like, it can have unintended actions and consequences because it's not typically generated by the same core community that writes the core engine. But it does give out like all the access that you can do in the extensions. And traditionally, when AWS supports an extension, we actually take that onus of providing the security and the performance and the upgradability of it. What we have found is like people still like to kind of like move faster on extensions on AWS, so they do not have to request AWS for every new extensions that they want to use. So we designed this open source project specifically to kind of allow customers to be able to write extensions on their own and without waiting for AWS to kind of deploy it for them. The way it works, it comes from a point of view of two personas. There is a builder persona and a customer persona who is using that extension. A builder writes the code of the extension using TLE. And the way TLE works, it doesn't expose out the file system. It creates those extensions through your normal database client software, through SQL statements. And a builder can then provide that extension directly to a customer, and the customer can install it on their own instances, Postgres instances, and be able to kind of like leverage the features that the extension provide. Our aim is like you no longer have to wait for AWS to ship your favorite extensions. You could write the extension using TLE and be able to kind of deploy them into any of the AWS instances out there. Moving on, the way this TLE works is you need to use a trusted language extension, trusted language, something like PL PGSQL, PL-V8, PL-Perl, because it definitely defines on the safeguards that an extension provides on Postgres. This is one of the reasons we specifically don't support C, because in C you cannot like really say the code is safe, because C, the way you know, is directly works into memory, can go and look up any of the memory in the database. So there are security concerns that we would have. So we restrict it to only trusted languages. And right now, traditionally you have JavaScript, Perl, and PL/PGSQL out there. Typically, customers still want to kind of like extend those languages to a bigger one. So today, I'm actually happy to announce like we are launching a new feature called PL Rust. Hopefully, by the time you step out and look on the news feeds from AWS, you will see a new announcement which says PL Rust is now supported for RDS for Postgres. It's supported in Postgres 15, which would allow you to write Rust functions in Postgres directly in RDS using the open source PL Rust project. It allows you to write functions which are as fast as C, possibly faster than some of them, but in a way that's safe to be deployed on Postgres and in a hosted manner. So with TLE, with PL Rust, we think there would be a whole new community of people who can write purpose-driven extensions for their applications. The extensions are useful because they run close to the data where it lies. So it gives you high performance functions out there and be able to kind of like do more directly in the database out there. Yeah.
For the extensions, like for the builder, is the builder building for their company, or is it like a type of marketplace where folks can go to different extensions that have already been built?
You could write and give it out to a marketplace out there. I do know of some communities are actually creating marketplace around TLE already, so that's happening. But like right now our aim is to kind of like give the power to the end user and to work directly with builders to create these extensions out. So right now, TLE has a few hooks already available out there. So like specifically the password hook is available. It's an open source project, so we do kind of like want more people to kind of like review and create their favorite hooks as a protection. What we look in that specific project is to kind of like, provide the right guardrails that the administrator would want control on their system. And that's the driving force, which is security in a larger deployment. And it's an open source project, and so it's like we welcome contributions from everybody around it. Right. So moving forward, another thing we are doing, we recently launched earlier in April in the Postgres is a new extension called PG Vector. Like I said, we want to kind of like still be moving fast on the extensions while we wait for more TLE supported extensions to come up. We'll continue to ship more extensions in RDS directly to kind of help customers to kind of meet their workload needs. PG Vector was a popular request for us. and partly due to the interest in large language models coming out there, we have heard requests for many customers to kind of store those vectors directly into Postgres. So I'm happy to get the PG Vector extension out, which is also supported in Postgres 15. We think the combination of vector, TLE, PL Rust all together will enable people to kind of write new workload strategies for their AI ML need, as well as like the extensions, to be bundled, to be more creative without waiting for AWS to kind of ship this functionality out. With PG Vector, you can actually store all your extension or your embeddings and vector into it. It already comes with the KNN type of index. So once you create that index, your searches could be really faster with these vectors up there. You can use extensions like AWS Lambda to integrate into other services like SageMaker and Amazon Bedrock, which helps you to kind of provide the generation and like inferences for these vectors. So with the combination, we expect most people would be unblocked from deploying their AI ML using PG Vector, TLE, PL Rust, and the AWS Lambda extensions out there. So I'm pretty excited for this release out there, which we have for customers out there. Traditionally, builders would be waiting for AWS to support these extensions to meet their needs. And with this way, you can actually now move faster. Gonna go a little bit quicker. We also announced earlier this year that we now support RDS blue-green deployments for RDS MySQL and Amazon Aurora with the MySQL compatibility. This is a standard practice. Like if you're using a DevOps model in your company, most people start with a blue, which is their current version of their production instance, and create like a green instance, which is containing the changes that they intend for their next setup to look like, and use like a blue-green deployment. And once they are satisfied with the changes, switch over to green. You can now do that with click of buttons in RDS, where from your existing setup, for example, like a database with say 3 read replicas, you could create like a green instance, which is an exact configuration copy of that, upgrade the databases, change the instance sizes, change the number of read replicas, make sure you're satisfied with it, and do a switch over to that new setup. It is the way it's designed behind the scenes, it gives you the protection that you need with the right guardrails. Because when you switch over, you want to make sure the last write that you've written to the original blue databases gets flushed to the green, and then the writes is resume on that one. So it kind of like gives you like the whole integrated experience. Experience of that with the setting, and then you could use that switching. We also kind of like include timeouts for it. So by default, the switchovers can vary somewhere between 5 seconds to 30 seconds. So the default is a 30-second timeout. When we do our checks whether it can be a successful switchover or not, if we think it's going to take longer than 30 seconds, we actually fail that switchover request and say the database is not ready to kind of like switch over within 30 seconds. So there is no impact to your workloads beyond that time frame. So this you could actually use to kind of validate your assumptions, and you can now change the settings if you want to kind of go longer. But this allows you to control the window of time that you want to keep between switching from your original instance to the new instance, giving you more control for your maintenance windows. The way I look at it is like this gives you quite a bit of control, because like, if you have the experience of doing managed major version upgrades for MySQL or Postgres databases, there is an unknown variability of time that it can take for these upgrades. With the blue-green deployment, you can be kind of sure like, hey, I can only switch over when the next thing is fully ready to kind of resume work for me. So this is a pretty exciting release from our side of it. We've seen like people actually liking it because it allows them to kind of break all their change management to as low as 30 seconds with this change out there. One of the things I did talk about it is we do provide a lot of guardrails already on it. It keeps checks on the replica lag. So if your replica lag looks like, hey, it could cause it to be longer than 3 seconds, then it would fail immediately. We also give that data out in your described blue-green deployment calls. So you could actually monitor on your own to see when the switchover would be ready. Because a lot of times, like when you create this new setup, the upgrade could take its own sweet time to finish. Then you start catching up all the changes. So we do give out those metrics for you to be to time it when it will be ready, and then you select the right window for your application needs to kind of do the switchover. So pretty excited about this feature. Yep.
Do both blue and green have to be the same MySQL version?
No. So you could start with MySQL 5.7. On the green side, upgrade it to 8.0. Do a lot of those changes, parameter changes, even schema changes if you like. You could actually make it writable and make the schema changes, be ready with it, and then do the switchover. The switchover tags all the replications happening. If it thinks the replications are not going and broken, it would then say, this switchover cannot happen because the replication is broken. No. Right, moving on. I want to go also talk about the innovations happening into Amazon Elastic Cache, which is a fully managed service that gives you a cache experience. Internally, you have two options to use it, the Memcache and Redis. So some of the innovations I want to talk about is on the Redis side of it. Earlier this year, Elastic Cache actually upped their SLA commitments from 99.9 to 99.99%. So that's the availability guarantee it gives you. This is available starting from the Redis 6.2 feature enabled out there with multi-AZ enabled on it. It's pretty exciting, like the improvements that were done to kind of reach these levels behind the scenes. It also, in February 2023, they announced we announced enhanced I/O multiplexing. What it does is back in 2019, Elastic Cache already improved the I/O plexing on the compute side by separating out different threads for managing compute and I/O threads in Redis. Most recently, what they did is they improved the I/O threads to kind of handle a higher workload, of multiple clients within those some threads. So based on recent benchmark data, if you use an R6G X large with 5,200 concurrent connection clients, you could see an improvement up to 72% improved performance with 71% lower latency by improving the multiplexing in the I/O threads for Redis. So that's a high growth improvement for Redis at high loads as such. So this is an exciting release for it. It now also supports IAM authentication. So if you are using IAM to kind of do your password credential management between different services in AWS from the users, Elastic Cache now supports IAM authentication, so you can just simplify it using getting the IAM token and use that as a way to connect to Elastic Cache. Moving on to Amazon Memory DB for Redis. There is a service that provides durable storage for Redis itself, which is called as Memory DB. It is designed to kind of give you durability in a way to get the fast get set features on Redis at the durable state. So the use case is slightly different from the Elastic Cache, where Elastic Cache is acting more as a cache for other data sources behind the scenes. In MemoryDB, it acts as your own durable state on it. Most recently, same thing for MemoryDB. It has upped the SLA to 99.99% of it. I'm going to go forward on it. It also actually now supports reserved nodes that gives you more savings around it, up to 55% cost savings if you use reserved nodes for MemoryDB. So that was a recent announcement earlier this year or late in reInvent in December. This is going to be useful because, like, the way it's designed is similar to RDS. Like, you can buy an X large and you get the savings. If you convert it to 2X large because your need has increased, you automatically still get 50% savings from your X large reserve nodes on it. So the savings will kind of like apply and be follow you for the different sizes that you grow into. One of the also a new feature that is released is data tiering. So for example, Redis primarily works best with everything in memory. So if there is a need that you can support higher latency, there is a data tiering feature now available with MemDB, where it would actually use the disk as an way to kind of like store more things for you that you can access out. The use case out there is if people needs are growing beyond a need of a single database out there, and only 20% of that is active database that you're constantly working on. The data tiering kind of helps you out, like, you don't have to redesign anything. You continue working with it. The least recently used data would go into the disk, but as you require it, it will come back up with a slightly higher latency than before. The ones in memory would be available in microseconds. When you do the pull from the disk, it would probably add about like 450 microseconds extra for your latency. So if you can sustain that for it, you would be able to kind of use this data tiering and support a larger amount of data on that same node. So with this, let's move on to the last database that I want to talk about it. I'm running out of time, so I'm going to move quickly. Is DocumentDB with MongoDB compatibility. The most recent feature of that is the elastic clusters that we support for MongoDB. MongoDB, the DocumentDB works in a way that it separates out the compute and the storage. And what now we allow you to do is take multiple of these combinations of compute and storage and scale it out into a larger cluster, which allows you to kind of like shard on top of it to support even petabytes levels of the documents that you can do on it. So this is that kind of like takes out your a requirement, like size could be the limiting factor to kind of use DocumentDB. And it now also supports MongoDB 5.0 wire protocol with field level encryptions. You can now actually support field level encryptions directly in your client and application itself. And when it comes to the database, it's already encrypted. Last but not the least, we also have Amazon Neptune, which gives you a graph database offering, which it recently actually had its own Graph Explorer visualization tool exploded, which allows you to do labeled property graph and resource description framework in a graph database and discover connections between the data without having to write separate graph queries. So it's a tool to kind of like do the visualization on top of your graph data. It's available as an open source project on the Apache license, Apache v2 license. So these are kind of like some of the innovations that have recently applied. And want to thank your time for today's presentation out here. If you have questions, I may be running out of time, depending on how quickly they kick me out of the room, but I'll be available here for questions. And just trying to make a pitch, there is also a debugging performance call for tomorrow at 2 p.m. where Raluca would be going over a lot of the scenarios, like on how you do debugging MySQL specific issues in the cloud. So going back, thank you very much. Yeah.
Just a quick question. This is from the beginning of the talk. Was there any data on the speeds of logical replication in parallel versus logical replication serial for the extension that was built out?
So the speeds typically depend on the size of the instance and other things. So for the first version, there is speed improvement, but the speed varies depending on the size, right? So for the open source, I think On the commit, they have some improvement numbers because there is a control that you can do with the number of parallel workers, and there is a test done. I don't have the results in front of me, but there is improvement that you do with the number of parallel workers that are used to kind of apply those things out, and that would change based on the number of active CPUs that you have in that instance. I don't have the numbers handy, but like it should be there in that mailing list for it on it.
Check it out.
Yeah.
Appreciate it. Thank you so much.
Thank you.
Great talk, thank you.
Thank you.